All right, this is Mole Podcast 4, and today I'm going to talk to you a little bit about calculating something called molar mass and doing some mole conversions. So in Mole 3, we went over the concept of a mole. So I have some examples here I'd like to share. But to calculate the molar mass, it's the mass of 1 mole of the element's atoms. That's molar mass, all right? Molar mass is going to be expressed in units. So again, let's think about it. The mass of 1 mole, grams per mole, okay? I have various examples here: zinc, carbon, lead, tin, copper, just a number of examples for you to look at, but these all represent 1 mole of these elements. All right. So if you look at your periodic table, you can see there might be a few discrepancies between these values and the official periodic table that we've chosen to use in this class, but the numbers will all be very close. All right. So the molar mass of a substance, for example, we're going to look at water, is its atomic, molecular, or formula mass expressed in grams. Okay, so you're actually going to take the fact, let's look at water. H2O is composed of those 2 hydrogens. So approximately 1 atomic mass unit per hydrogen, and that 1 oxygen at 16 atomic mass units. So if we take those and add them together and express them in grams, we have the molar mass, or grams per mole, of water. Using your values on the periodic table, you should get 18.02 grams per mole. All right. So again, if you look at the periodic table here, you'll see, and I don't want to obsess over sig figs. I want you to simply pay attention. You'll hear me say that throughout the course. But if you take the 2 times 1.008 and you add 16, you're going to get this value here for the molar mass of water. Okay, so the first example I want to look at, we're going to calculate the molar mass of aluminum sulfate. Now, you know by now, I'm going to typically give these to you in word form, and you're going to have to apply your knowledge of nomenclature and put it into a formula. So, as I always say, pause the podcast, give this formula a shot, and then once you get the formula, we're going to begin talking about how do I find the molar mass of aluminum sulfate. Okay, well, you're going to have to look at the fact that it's composed of 2 aluminum, a total of 3 sulfur, and 12 oxygen. So take a look at this one. I want you to try the next one. So the molar mass of this compound is 342.14 grams per 1 mole. Okay, so our next example here of calculating molar mass is calculate the molar mass for sodium dichromate. So pause, give it a shot. Sodium dichromate, composed of 2 sodium, 2 chromium, and 7 oxygen. If you take those values from your periodic table and plug them in, add them all up, answer 261.98 grams per 1 mole of sodium dichromate. Example number 3. What is the mass of 3.2 moles of oxygen atoms? 3.2 moles of oxygen atoms. Now I want you to grab your mole map here. Okay? We are being asked to go from moles, okay, to mass, or grams. So this mole map is telling you the way is through using that conversion factor of molar mass, or grams per mole. Okay, so that's how you use the mole map. All right, so we're going to start off with what we have here. We have 3.2 moles of oxygen. Okay, I put that over 1. And let's see here. So moles on top, moles on bottom. I need moles to cancel. I want to end with mass. I want to end in grams. So the connection here is that in 1 mole of oxygen, you're going to have 16.00 grams of oxygen. Cancel. Pause. Make sure we're good. We want mass. Mass of what? We want mass of oxygen. All right. So we have a limiting factor here of 2 sig figs, but we're going to go ahead and multiply across the top here. And you're going to get 51.2 grams, but we need to be aware that you're just going to have those 2 sig figs there. So we're going to simply say 51 grams of oxygen, and that's going to be our final answer on that one. Okay. Next example. How many moles of water are in 1.8 grams of water? So now we're going from grams to mole. So we're going from grams, converting into moles. So if you use your mole map, that'll tell you, okay, the connection here, we're going to use the molar mass. All right. So let's go ahead and start with what we know here. We know we have 1.8 grams of H2O. I'll place that over 1 times the molar mass here, 18.02 grams. Notice how grams is on bottom now because I want to end in moles per 1 mole of H2O. Okay, grams cancels, and we're going to end up with what we're going for here, which is ultimately moles of water. And you are going to get 0.0998 mole of H2O. But then we need to pay attention to our sig figs. Probably better express this with a couple sig figs. So let's go ahead and go with 0.10 moles of H2O for our final answer on that one. Okay? All right. Example number 5. This is our last example here. Smelling salts are used to revive unconscious athletes. A capsule of smelling salts contains 500.0 milligrams of ammonium carbonate. How many moles of ammonium carbonate would this be? All right, first and foremost, pause and calculate the molar mass for ammonium carbonate. All right, ammonium carbonate. And you should get, for this one here, 96.09 grams per mole for the molar mass. All right, we know we're going to need that. You can pull up the mole map again, and we have one additional dimension that we need to go through, and that would be converting milligrams into grams. Okay, so we start with 500. Let me go ahead and start over there. 500 milligrams of ammonium, NH42, CO3, and I'm going to put that over 1 times. Okay, so I need milligrams to convert and factor out. So I'm going to say, well, there's 1,000, and that is an exact number, 1,000 milligrams in 1 gram. So that's going to knock out my milligrams. So now I'm in grams. But remember, what are we ultimately trying to get to? Moles. All right, so we're going to continue on our little journey here. And we're going to say, all right, I know I need grams to cancel. The connection, molar mass. So using the number you calculated, there are 96.09 grams of ammonium carbonate in 1 mole of ammonium carbonate. And I will continue writing this, but I am trying to be aware of your time. But I do want to accentuate that we don't want, lots of naked numbers. You kind of need to keep track of things here for you. And equals. So make sure we're good. We have moles here. Sometimes I'll circle it. We should be all set to plug and chug. In other words, let's get this into the calculator. And you will get a final answer of 0.0052 mole of ammonium carbonate. Okay, now look at this number here. I have expressed this with 4 significant figures, and if we're paying attention to sig figs, 4 is a good number. So our final answer here, we're going to call it good for that problem. All right, so we're going to go ahead and close this out now. You'll be happy to know you can finally get started on this problem set. So work through, practice some 1-step, maybe 2-step mole conversions. Get a lot of practice calculating molar mass for various binary and ternary compounds. And then that's going to lead us into our next podcast where we look at multi-step moles, percent composition, empirical molecular formulas. We're going to just have a lot of fun in this unit. So I will see you in class. Thank you.